First generation systems, or 1G. The original cellular telephone networks provided analog traffic channels. The original ones provided analog traffic channels. These are now referred to as first generation systems. Now they call them first generation systems. Which ones? The analog traffic channels. Since the early 80s, the most common first generation systems in North America has been what's the most common? It's called the AMPS, the Advanced Mobile Phone Service. This approach is also common in Latin America, South America, Australia, and China. In this AMPS, the first generation, two 25 megahertz bands are allocated to AMPS. Each of these bands is split into two to encourage competition, so that in each market, two operators can be accommodated. An operator is allocated by 12.5 megahertz in each direction for its system. The channels are spaced 30 kilohertz apart. These 12.5 in each direction. The channels are spaced 30 kilohertz apart, which allows a total of 416 channels per operator. So if we multiply 416 times 30, the result is 12 and a half. 12 and a half per operator. Out of these channels, 21 channels are allocated for control. 21 just for control. To carry the calls, how many are left? We subtract this 21 minus, or 416 minus 21, leaving 395 channels for calls, to carry calls. The control channels are data channels operating at 10 kilobit per second. The control channels, these 21 channels, are data channels. They don't carry voice, they carry data. At what rate? At 10 kilobit per second rate. Just remember, that was in the 80s, something between 35 to 40 years from now. That's an old stuff relatively in the mobile industry. The conversation channels carry the conversation in analog using FM modulation, frequency modulation. That was in the 80s. AMPS uses analog traffic channels. The question is, how about the control channels? The control channels are not analog. They use digital and operate at this very low speed, 10 kilobit per second. Analog, they don't count by bit per second. That's just the data, the 21 channels only. All right? We are still in the first generation. European Total Access Communication Systems, TACS, deployed in 95, almost identical to AMPS that's used in the States. AMPS used in America, North America, the States, South America, Latin America, Brazil, and these countries, Australia, and China, AMPS. This TACS is almost identical to AMPS, except the channel bandwidth is scaled to 25 kilohertz instead of 30 kilohertz. The the channel is 25 is narrower. Uh, Skilled 30 kilohertz apart. Okay. So after each 30 kilohertz, there is a channel. Here, it's it's more efficient a little bit. It uses more. It uses more channels. Allow the use of more channels. So if we divide this 12.5 mega divided by 30, this is the result. 12.5 mega divided by 25, it's going to result more channels. So TACS provides more channels. In other words, it provides more users, more communication channels. In the analog, it means more users. The drawbacks. What are the drawbacks? What are the disadvantages? What are the problems? What are the weaknesses? The first one is poor voice quality because it's analog, so the distortion stays in. Poor battery life because in the 80s there's no efficient use and there's not nanotechnology like now. Limited capacity. Of course, there is a limit. The number of subscribers, number of users. Here it's limited to 416. Well, it's 395 because we have to remove the 21. So the 395 versus a little bit more here. Limit capacity. There is no security, no encryption, no security. Everything is subjected to intruders, hackers. Poor handoff reliability, the transition between cells. There is a poor handoff reliability. The handoff is a mechanism that ensures the phone call does not get interrupted while the user moves between a cell to another cell, between the geographic area covered by a base station to another geographic area covered by the next base station. So poor handoff reliability and large phone size. The phone size used to be very large. That was the first generation, and I'm gonna stop the video right now. Thank you so much.